Hey there, y'all. We're going to look today at section 1.2 on dimensional analysis. In this section, we're going to just cover the first two examples today, and then we'll do example 3 in the next lesson video, just breaking this up into 2 days. So here's the objective, that you'll be able to convert metric measurements and customary measurements between each other and be able to convert units as necessary. And this falls under the standard NQ1, using units as a way to understand problems and to guide solutions of multi-step problems. Choose and interpret units consistently in formulas, and choose and interpret the scale and the origin in graphs and data displays. And so again, this is setting us up for what we can do later on in algebra. So let's look at a definition here. Dimensional analysis is a way of using units to help solve problems involving what? Involving measurements. So we can use the dimensional analysis to convert units by setting up ratios of two equivalent measurements, such as 12 inches over 1 foot. Sometimes you'll see these set equal to each other. So like 12 inches equals 1 foot, right? Or 5,280 feet equal 1 mile. But when we set them as a fraction, we call them conversion factors. So with that information and the chart that we've worked on, either you did it as your homework or we've done it in class, you're going to be looking at problems to use these conversion factors to convert units from one measure to another. So let's look at example 1. In example 1, the body of a large adult male contains about 12 pints of blood. Using dimensional analysis, we want to convert this to liters. And we're given that there are about 2.1 pints in each liter. So let's see how we set up this problem. Our initial value is the 12 pints that we see here. And then we take our conversion factor, and it's 1 liter to 2.1 pints. Now, which one becomes the numerator and which one becomes the denominator is very important because we want the units to cancel. And so what's going to happen in this problem is we want the pints here and the pints here to be able to cancel. Now, if they're both in the numerator, are they going to cancel when we multiply this? No, it'll actually square the units. So we have to have one in the numerator and one in the denominator to get them to cancel. And so when we do that, we'll now multiply these fractions straight across. Remember, when we multiply fractions, we take numerator times numerator and denominator times denominator, and we multiply those straight across, and then we'll reduce our answer. So let's see what that looks like. So as we multiply this straight across, we get the 12 times the 1, which is 12, and our denominator would be 1 here as well. And so 1 times 2.1 gives us the 2.1. Our pints canceled, leaving us only with liters. And so we get 12 divided by 2.1, and that's going to give us our final answer. And so when we do that division, we get 5.7 liters, and that is with the appropriate number of significant digits because our original value had 2 significant digits here, and also our pints had 2 significant digits. So our final answer does come out with 2 significant digits. As we go through a lot of these problems, we're not going to care so much with the significant digits. We'll round them to a certain number of places, but we do want to keep in mind that those digits may not be significant in our final calculations sometimes. And so let's look at example B. In example B, C, and D, we've got 3 examples here of converting units, and these are very straight conversions. So I want you to pause the video for a second, follow the model that we just did in A. Use your conversion factors for these. So in B, we're converting from feet to inches. Think about how many inches are in 1 foot. In C, we're converting from inches to yards. And so we've got to do 2 conversions there. We've got to convert from inches to feet, and then from feet to yards. And so if you get stuck on that one, come back to the video and watch C. And then finally, D, grams to milligrams. And so again, that's what we talked about in class about the metric system and going from the base unit to a different set of units, so going to milligrams. So pause the video here, try those 3 problems, and then come back and let's see what happens with these 3 problems. All right, I hope you paused the video because here we go looking at B. So in B, we've got 1 foot is equal to 12 inches. That's our conversion factor, right? So we're going to set that up as a fraction. And as we look at this problem, we've got our 3 feet out front, and we want that to cancel. And so how do we get that to cancel? Well, we're going to, again, want our feet and our feet in different places. We want 1 in the numerator and 1 in the denominator so that it will cancel through this division. And so the feet here and the feet here will cancel. And so we're going to end up with 3 times 12. 3 times 12 is 36. And our final units are in inches. So the final answer here is 36 inches. All right, so as we look at example C again, I told you that we have to do two conversions here. We first have to do from inches to feet, and then from feet to yards. And so we have to deal with two conversions. So our first conversion is the 12 inches becoming 1 foot, and the 3 feet becoming 1 yard is the second. And so let's see how that sets up in our fractions. So we see our 4 inches here, and that's our initial starting value. And then our first conversion factor is the 12 inches to 1 foot. And again, we want our inches and our inches to cancel. And so we're going to put the feet on top, the inches on the bottom. And so those will cancel. But I'm not stopping at feet. I need to go to yards. And so the feet now need to cancel. And so that's why our second one comes in, 3 feet to 1 yard. And I get the only unit left is yards. And so now we multiply straight across. So again, we'll go 4 times 1 times 1, that's 4. And then again, that we can pretend that this is a fraction here with a 1 under it. So 1 times 12 times 3, so that's 36. And so we get 4 over 36, and that's going to reduce to 1/9. So our final answer is that this is 1/9 of a yard is equal to 4 inches. All right, so our last one on D, 35 grams to milligrams. So remember that there are 1,000 milligrams in 1 gram. And so we're going to use that conversion factor to convert this over. We see our conversion factor of 1,000 milligrams to 1 gram. And so then we're going to plug this in and set up our fractions. So 35 grams out front, 1,000 milligrams is the numerator, 1 gram the denominator, because again, we want the grams and grams to cancel. Again, 1 in the numerator, 1 in the denominator, right? And so we're going to end up 35 times 1,000. 35 times 1,000 is 35,000. So in 35 grams, there are 35,000 milligrams. So there we go. 35 grams, 35,000 milligrams. That's our final answer there. So again, when you're dealing with just converting a certain measurement to another measurement, you've got to use those conversion factors to your advantage. And so now we're going to look at example 2. This is our last of examples today on converting. Now, these are not just one single measure. These are rates. And so we're going to see something like in miles per hour, or in the case of like example A, kilometers in so many hours. Or we might see it in meters per second and have to convert it to something else. And so we've got to use our conversion factors that we know to be able to convert from one to another, and not just dealing with stuff in the numerator, but also stuff in the denominator. So as we look at example A, a cyclist travels 105 kilometers in 4.2 hours. Using dimensional analysis to convert the cyclist's speed to miles per minute. Write your answer with the correct number of significant digits, and remember that 1 mile is approximately 1.61 kilometers. So we're given the units there for that one. And so let's see our conversions here. We've got to think about what we're converting. So we first have to convert our kilometers to miles, and we have that conversion factor. 1 mile is 1.61 kilometers. And we've also got to convert our hours to minutes. So we've got to do 2 separate conversions in this problem to get us through this. Okay, so let's look at what this is going to look like. So as we first start our fraction, again, we're going to write this first part as a fraction. So 105 kilometers over 4.2 hours. So there's our fraction here. And then we're going to convert our rates. And so the kilometers need to cancel with the kilometers in the denominator. And so we're going to put the 1 mile in the numerator, 1.61 kilometers in the denominator, and those will cancel. But then I've also got to convert the hours. So the hours have to cancel, and we're converting those to minutes. So if the hours started in the denominator, we need to cancel them in the numerator, and then that gives us the miles in the denominator here. So again, we want the 2 rates that are the same to be in opposite locations. 1 in the numerator, 1 in the denominator, so that they will cancel out with this division that happens. Okay? And so now we're going to multiply everything straight across. So we're going to get the 105 times 1 times 1, that's 105. And then we'll do the 4.2 times the 1.61 times the 60. And so let's see what that gets us when we do all that in our calculator. So putting that in our calculator, we get 105 miles over 405.72 minutes. And when we divide that, we get 0.259 miles per minute. Now, when we talk about reducing 4 significant digits, we don't mess with significant digits until the very final part of the answer. And so when we look at our original values, we don't deal with any of the conversion factors, but our 2 original values, the 105 and the 4.2, which one's more precise? Well, they're in different units, and they're not units that convert to each other. And so again, we've got to look at place value at this point. And so the less precise is the 105. And so that has 3 significant digits. So our final answer can also have 3 significant digits. And so that's why the answer is 0.259. Originally it's 0.258, and I believe 6 is after it. But because it's a 6, it rounds that 8 up to a 9. Okay? Let's look at example B. We've got a tortoise that walks at 52.0 feet per hour. That's pretty slow, isn't it? We're going to convert this speed into inches per minute because that's a little bit better for a turtle walking across, right? So let's look at that conversion fact. So as we look at it, it's 52 feet per hour. And again, we've got the decimal point 0 here. We'll drop it just for the calculations, but we need to understand that that is a part of our significant digits for this problem. So we got the 52, and so we're going to convert our feet into inches in this problem because we're going from our feet here, right, to our inches. And so the feet in the numerator will cancel with feet in the denominator, and that gives us our inches in the numerator. And then we've got to convert our hours down to minutes. And so our hours down here cancels the hours up here, right? Again, numerator, denominator, got to cancel them out across, right? You can't keep them in the same line. If they're in the same line, they don't reduce, okay? So we're going to multiply this across. We get 52 times 12 times 1, and then denominator 1 times 60. And so let's see what that gets us. Multiply all that across, 624 inches over 60 minutes. And so reducing that down, we get that is going to be 10.4 inches per minute. And if we go back, the only units we had in the original problem was the 52.0. And so that means our final answer can have 3 significant digits in this case. And so that is why we get 10.4 inches per minute. All right, the last example we're going to look at today, again, we'll look at example 3 in the next video for the next lesson. A go-kart travels at 21 miles per hour, and we want to convert this to feet per minute. So I want you to try this one on your own for a second. I want you to pause the video here. Think about what conversions you're going to need to use, right? We're going to convert the miles down to feet. We're going to convert the hours to minutes. So think about those rates that we need. Pause the video, and then try it out, and then we'll look at the answer after this. So pause now. All right, I hope you paused. So here we go, looking at this. So we've got 21 miles per hour converting to feet per minute. So let's write this fraction. So again, we're going to look at how these go, right? So 21 miles per hour, that writes as one fraction. And then we'll take those miles and convert them to feet. And so the miles in the numerator will cancel with miles in the denominator. You got to make sure those cancel. Again, numerator, denominator. Can't stress it enough. Make sure they're in opposite places, because if they're in the same place, they don't cancel. All right, so our next thing we need to do is convert our hours to minutes. And so our hours here in the denominator will cancel with hours in the numerator. And again, we're writing these fractions from knowing that 5,280 feet is 1 mile, or 1 hour is 60 minutes. So that's what we're converting there. And so we'll multiply straight across 21 times the 5280 times the 1, and the 1 times 60, that's obviously 60. And so let's see what fractions that gets. We cancel this all out, we get 110,880 feet over 60 minutes. We divide that in our calculator and get 1,848 feet per minute. Technically, we would need to deal with our significant digits, right? There would only be 2 significant digits in 21, but because it's an exact unit, we're going to round this also to the exact unit here. And so we're going to get 1848 feet per minute. We're not going to round that to like 1800 with only 2 significant digits. We want that to be as precise as possible. And so leaving it rounded to the same place is appropriate here. Okay, so that's it for this lesson. Again, that is 1.2a. We're going to look at the last part of this lesson in the next video. So make sure you do the Google form. Make sure you answer the questions there. And I will see y'all next time.